So now we have this new tool, this square root method for solving equations, solving quadratic equations. And it's great. I mean, in terms of flexibility, it beats factoring hands down because theoretically it can be used to solve any equation that has that kind of general shape, that x plus something squared equals a number. But here's the problem. Very few equations look like that, right? That's a very specific and unusual kind of form that we need it to be in. So to really make this work, to make this generally useful, what we need to be able to do is to take kind of a generic equation like ax squared plus bx plus c equals 0 and come up with a way to manipulate it so that it looks like this thing up here. And it turns out there is a way we can do this. There's a special number, right? And we saw this number derived, right, in the previous lecture, if you've watched that one. The number we need to add to both sides of the equation to make this into a perfect square is b squared over 4a. All right, so let's see how we can do that, right? Let's look at some examples. I got this thing. It doesn't factor. You're welcome to try, but you're not going to be able to factor this. So I'm going to try using my new completing the square method. I'm going to get this special number. It's 6 squared divided by, well, I got that backwards, didn't I? Sorry. 6 squared divided by 4 times 1. If that's 36 divided by 4, that's 9. All right, so here, first I'm going to move the 12 over to the other side, because we know that to use this square root method, we have to have variables on one side and a number on the other. So let's move the 12 over, and this becomes x squared plus 6x equals negative 12. And I'm going to take my special number here and add that to both sides. All right, now you see this did do what I needed. This left-hand side, this is x plus 3 squared. And that equals negative 3. So this is our square root situation, right? Our square root method works here. This is, you think, if taking the square root of both sides, x plus 3 equals plus or minus the square root of negative 3, which is, let's see, that's plus or minus I times the square root of 3. And I'll subtract 3 from both sides and we're done. X equals negative 3 plus or minus I times the square root of 3, and that's it. There's my answer, right? This seems to be working, which is excellent. So let's try another one here. Try doing this one on your own. Try pausing the presentation here and see if you can work this one out, see what you come up with. All right, so I'm going to start the same way. I'm going to move the 1 to the other side. X squared minus 14x equals negative 1. And let's see, what am I going to add here? My number is b, that's 14 squared, divided by 4 times 1, and I believe that's going to be 49. All right, so let's add a 49 in here and over here. And now, yeah, this left side does factor. This is x minus 7 squared equals 48. Now we can square root x minus 7 equals plus or minus the square root of 48. And I can simplify this a little, right? 48, that's 16 times 3. So x minus 7 equals plus or minus 4 times the square root of 3. And add 7 to both sides and we're done. X is 7 plus or minus 4 times the square root of 3, and that's it. All right, there's our answer. This method is working. All right, so how about this one? Right here, it's just a little different. There's a number in front of that x squared, but that's okay. Our formula accounts for that. Let's see, let's move the 1 over. 2x squared plus 14x equals 1. And the number I need to add is 14 squared divided by 4 times 2. Let's see, on the last one, 14 squared divided by 4. That was 49, so this is 49 halves. Okay, well, I'm okay with that, right? There's a fraction, but sometimes the answers have fractions in them, so let's put 49 halves in here. Now, like, it's not clear right off the bat how that left-hand side is going to factor, but let's do this. Let's clean up a little bit. Multiply both sides by 2. That's going to get rid of the fractions, right? So this becomes 4x squared plus 28x plus 49 equals 2 plus 49. And now this makes sense to me. I got a 4x squared and a 79. This is going to be 2x plus 7 squared equals 51. Square root of both sides, 2x plus 7 equals plus or minus the square root of 51. Subtract 7 and divide everything by 2. X is negative 7 plus or minus the square root of 51 over 2. And there's my answer. Works fine with a number out in front of the x squared term. So why don't you see if you can do this one on your own. Go ahead and pause it real quick. See what you can do. Come back and we'll go over it together. All right, so the first thing I'm going to do is, excuse me, is move that 1 over. I'm going to make this 3x squared plus 12x equals 1. Let's see, my special number here is going to be 12 squared divided by 4 times 3, which is 12. And I'll add that here and here. Now, it's not looking like I can factor that left-hand side, but look, notice there's a greatest common factor I can take out. I can pull out a 3 and make this x squared plus 4x plus 4 equals 13. And now that is a perfect square. This is 3 times x plus 2 squared equals 13. All right, now before I do square roots, let's move that 3 over. Let's divide everything by 3. X plus 2 squared equals 13 thirds. Now I'll do the square root. And look at how I write this. I'm going to make this plus or minus the square root of 13 over the square root of 3. And I keep them separate because I know I want to rationalize the denominator. I need to get that square root out of there. So I'm going to multiply the top and bottom by the square root of 3. And this becomes plus or minus the square root of 39 over the square root of 9, which is just 3, which is what I needed. Right? No square roots of the denominator anymore. Now we're almost there. Now let's subtract 2. X is negative 2 plus or minus the square root of 39 thirds. And I want to combine these together. So let's do a common denominator. I'm going to make this negative 2 into negative 6 thirds. And now I can combine these two together. Negative 6 plus or minus the square root of 39 over 3. And there's my final answer. That's it. We're done. So this is the completing the square method. And look, it's a little clunky, right? I mean, it's great. It's a powerful tool. It lets us, really gives us a method we can use to solve any quadratic equation. But there is sometimes some kind of messy work with factoring and square roots and so forth. Ideally, what we would like, and this is going to be the subject of the next lecture in the series, is a formula. Right, a formula that I can just put those coefficients, the 3, the 12, and the negative 1 into, and have the answer just kind of come out. Right? So that's going to be the next lecture in the series, where we're going to talk about this thing is called the quadratic formula.